So the question number is from the Leetcode 3593, and the title is saying that minimum increments to equalize leaf path. Right? As the question suggests, we have to equalize the leaf path. What is this? So the statement is saying that you are given n, and you can say an undirected tree, means there is no direction of the tree we have given, and its root is at 0, node 0, and there is n number of nodes given from 0 to n minus 1. We have, it is given, right? So we also given the edges, that you know what is edges contains. So edges will contains like this, and we have given, and the cost we have given. What is the cost is there? So each node I has associate cost given by cost at I, that represent the cost to travel that node, right? So let's suppose this is what 0 and 1. So this, there is some cost at I will be there, right? So cost at I is what? 2, 1 and 3. So these are the costs to travel the index, right? If we talk about the 0, 1 and 2. So to travel the node 0, right, it will take how many cost? 2. So as you can see, the root node is 0 and its cost is given 2. If we'll talk about the 1, it is given 1. It is, if we'll talk about this 2, it is given 3. Like this we have given cost, and these are the edges and the number of nodes we have given, right? So score of the path is defined as the sum of cost of all the nodes along the path. So what is our goal? Our goal, your goal is to make the score of all root to leaf path equal by increasing the cost of any number of nodes by non-negative amount, and then we'll return the number of nodes whose cost must be increased to make all the root to leaf path score equal. It means, let's suppose we have given this 0 node, as you can see here, right? Node 0 is the root node, node 0 is the root node. Then we have given one first leaf is 1, and another leaf we have given is 2, right? These things we have given. Let's suppose as per the example, the cost to travel this node is 2, and for 1 we have given what? 1, and for 2 we have given 3, right? If you observe, right, if you observe, what you will observe, that there is 2 paths we have given, right, from root to the leaf node. So either you will go this way, or either you will go this way, from root to leaf. We are talking about the root to leaf path, right? If leaf path, okay. So if we'll consider this path A and we'll consider this path B, right? So there will be 2 paths, right? For this path A, the score it will start from 0 to 1, and for a score a path 0 to 2, there is a path is 0 to 2, right? So if you'll find the score A and B, right, you will understand what are the score of these 2 paths. Let's suppose for path A, the score, the node is from node 0 value is 2, right, the score, and for 1 we have 1. So how many it will come? 3 it will come. For B, path B, the score of 0 node is 2, and 2 node is 3. So we'll get how many? We'll get 3. Sorry, 5. We'll get 5, right? Give me 1 second. This one. So first we'll get what? 3, another will get 5, right? Now if you see, these 2 are not equal. Path A and path B score are not equal. It means score are not equal, means the score doesn't match. So we need to fix it. How we are going to fix it? Means we understand the goal. What is the goal? Means we have to make all the path score equal. So how are we going to make it? Let's suppose if we'll take, which one is max? This is your max, right? So if this is max, right, what we need to do? Just let's equalize the score by increasing node cost. Which one we have to cost increase? So max is 5. 5 minus score of A is what? 3. It means 2. And for B, 5 minus 5 equal to what? 0. Means B doesn't need to do anything, but score A we have to increase by 2, because this is the only path which has the less score, right? Means path A having the score, right, is shorter by 2. Understand? So we can increase the nodes 1's cost by 2 from 1 to 3, right? So now the new cost will be so the new cost is not this one, the new cost is get updated. We have to update this cost. So this new cost is become what? How many we have to add? 1 plus 1 plus will do 2. This is 1. Give me 1 second. Right, just remove this one. Now this will become what? 3. Just still that. Now it is 3. Previously it was 1. Now it become what? 3. Previously it was 1. Now it become what? 3. Understand? Means if we'll calculate this path, now 2 plus 3 is 5. Now this 2 plus 3 is also 5. So both equal to 5. Means now both score is 5. Means now we are fine. Understand? Now the main concept is how many nodes has been changed, right? Only one node change, that is node 1, correct? So node 1 has been increased from 1 to 3, right? Its value. So the minimum number of nodes increase is what? We'll say minimum number of nodes increased. How many? Equal to 1. And this is it saying that how many it required? 1. And so we are getting the output is 1. Understand? It's very easy problem. Just you have to understand the concept. So now understand how the code works, right? So as you can see, let me increase little zoom. Okay. So now think, the very first step you need to create the adjacency list, right? So to create the adjacency list, right, because a tree is represented as a undirected graph, and so we need to create the adjacency list. So right, to create the adjacency list, you have to take, let's suppose we'll take a list of, we can say, all the neighbors, right, in here in the adjacency list, right? So we can keep it here, right? So how we are going to initialize the adjacency list with n nodes? Means you have to go for all the edges, right? So each edges you will get the edges, and you will get u and v, and you have to map it like this, right? You have a neighbor v and we have the neighbor u, because it is undirected, right? When it is undirected graph, we have to map like this. Means u is attached to v, v is attached to u. There will be the cost that we will talk about later, right? Okay, so for each edge, what we will do, let's suppose the edge is nothing but u and v, right? U and v. So both nodes are added to each other in the list because this tree is undirected. Understand? Now start with the DFS from the root node. So to get the root node, you will have to pass the root node is 0, then -1 because there is no parent is there, and because the 0 node doesn't have any parents. If it doesn't have parent, you will write -1, right? Then you will pass this adjacency and the cost. So the root node is 0. We'll call the DFS to process the tree, and we'll pass -1 because the parent of root node is -1. There is no parent for the root node, right? Then we'll process all the you can say tree nodes, and then you will return the count, right? So we'll update the count in the DFS, right? How we are going to do? Let's understand. Okay. So very first step, you need to do what? You have to define the function, right? And you will write what? Node parent adjacency list and its cost, right? You will check the base case condition. If the base case is leaf node, if all the connected nodes of the parent having, right, it means parent is not equal to -1. It's connected to parent, but it's not parent, right? If it is this case, means this is a leaf node, right? So when we are talking about the leaf node condition, right, so what we should understand, that if a node has connections, right, that connection is the parent, it's a leaf, right? So we will return the cost of the leaf node end of that node, right? And so you will write what? Cost at node, and you will return it, right? Then we'll talk about so you have the children, right? So what we need to do, we'll traverse the children using the DFS again, right? So we'll take the child's path, right, like this at line number 33, and then you will recurse all the children. Understand? To recurse the you can say traverse the children using this DFS, what we need to do, will adjacent.get you will do the adjacency list dot get, you will pass the current node, you will get the current nodes, all the neighbors, right? And for each children we will exclude the parent to avoid going back to a DFS, right? And for that we'll check if a neighbor is equal to parent, means don't go back, just stop it here, don't do the DFS again, right? You do a DFS but don't go back there, right? Then we'll track the minimum child cost, right? How? We'll do the DFS, neighbor will pass, its parent will pass, and the because this is the parent and its parent having all the neighbors, means all the leaf node. Neighbor is nothing but the leaf nodes, right? And node is nothing but your parent node. Okay, and the agency cost will pass, you will get the child cost, right? And then we will pass then we'll add what? Child path paths dot add, you will pass you will add the child cost, all the cost will add into the this child path, right? Like we have 1 was there, 3 was there, right? Those things we will add into the child path, and then we'll check the maximum, right? What is the maximum of the sum, right? That you will add here, where at the maximum. So we'll find the maximum one, what is the child cost max one, and you will have the value here, right? Then because see, we want to collect all the child path from the cost itself, right? And so we have to collect all the child path cost in a list, and then you will get the maximum here, right? Okay, so once you will recurse this right, what we need to do, we have to recurse all the children, you will find the child cost and you will find the maximum, right? Means now it's time to count the nodes that needed the increment, right? So you will traverse the child path, and you will get the child, each time you will get the child cost, and you will check if child cost is less than maximum, so how much increment we require, right? So we'll do the count plus plus, right? So this path needs the increment, how many nodes required to get incremented, right? But when it was 1, we have did 1 plus 2, it become 3, right? So how many was required? Only 1 was there, so you will do plus plus, so it will keep traversing the element and you will get plus plus, right? Means first it will come what? 2, then 1, then 3, right? You will get, so you will check that and you will see the max count, how many child having what? Either 1 was there or 3 was there, right? So you will say how many it is required. The maximum is required what? Is 2, right? So 1, it was 1 and 2. Remember the child path was what? For node 0 was it was 1 and 3, right? And parent was what? 2, right? Parent was 2, right? So when we'll traverse this, so this is not required, we required in where? At here. So when it will come here, the child cost will come what? 1 at this time, right? So we'll increment only this one, because the maximum is 2. What is the maximum? Maximum was this, maximum was is 2, right? And so if it is less than this, so only one is less than, so you'll do plus plus and you will return it, right? You will do what? Cost at node, and you will do maximum, and you will return the total cost. That is called DFS leaf, right? You will get it like this. You will do the DFS and you have all the counts, right? So that function you will give the DFS, but this function will return you the count. Understand? So this way we'll write the code and we'll return the count, how many nodes we need to, how many nodes we require to update, right? Okay, so thank you guys, I hope you understand this video. If you have any doubt in this video, please comment and let me know if you have any doubt. If you understand the question, please write the time complexity and space complexity in this video, so I will give the heart and other people will understand the complexity in this problem statement. Okay, thank you guys, thank you for watching this video.